Hey everybody, welcome once again to Welch's math class. We are into Module 4 now, and in Module 4 we have been working a little bit on adding and subtracting fractions. A big piece of adding and subtracting fractions, a skill that you'll need to have, is to be able to find the least common multiple of a set of numbers. Let me give you a quick definition. The least common multiple is the smallest number some set of numbers will go into. So when we talk about the least common multiple of 6 and 8, a lot of people want to say that it's 2 because they're thinking of the smallest number that goes into 6 and 8, and so they think of 2. But that's not correct. What we're looking for is the smallest number that 6 and 8 will divide up into. And so the smallest number they both go into is 24. We can check that by realizing multiples of 8. If we do multiples of 8, we would get 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. And then if we check that against the multiples of 6, we would get 6, 12, 18, 24. And the first number, the smallest number that comes up on both lists is a 24. So that's one way to find a least common multiple. So the LCM, least common multiple of 6 and 8, is 24. Now, many times we'll be dealing with large numbers, and so for example, with the numbers 24, 42, and 54, and we want to find the least common multiple, the smallest they all go into, we won't be able to just look at those and tell what the LCM is. We'll need to have another method. And so what I want to get you guys to think about here is the upside down division method. With prime factors. Okay, remember the prime numbers, by the way, that we're going to work with are 2, 3, 5, 7, 11, 13, and so on. So what we'll do is we'll use the upside down division method on these numbers to find the least common multiple. We'll use that method on all three numbers at the same time. And so we're going to start by taking our smallest prime number, 2, and seeing if it'll go into any of these. Well, it so happens 2 will go into all of them, so we'll put a 2 here. Divide 2 into 24, we'll get 12. Divide 2 into 42, we'll get 21. Divide 2 into 54, we'll get 27. Okay, now as we look at our new set of numbers here, we'll also stay with the 2 and look, does 2 go into any of these? Well, 2 still goes into 12. Now since 2 goes into 12, we'll divide 2 into 12 and get 6. Now 2 does not go evenly into 21, so we leave the 21 alone, and 2 does not go evenly into 27, so we leave the 27 alone. I see 2 still goes into 6, so I'm going to use 2 once more. I said 2 and I wrote 3. Let's try that again. I'll use 2 once more. 2 into 6 goes 3. Of course, 2 won't go into 21, so bring it down. 2 won't go into 27, so bring it down. Now 2 will not work on any of these numbers. So I'll go ahead and I'll go to 3, because I know 3 actually works on all of them. 3 goes into 3 one time, 3 goes into 21 7 times, and 3 goes into 27 9 times. I see I can still use the 3 on this 9 right here, so 3, this stays a 1, this stays a 7, this drops to a 3. I can still use 3 one more time on that 3 right there, so I get a 1 still, a 7 still, and a 1. Now 3 doesn't work anymore. My next prime number up is 5. 5 won't divide any of these. 7. 7 will divide that 7. So we'll do a 7 here. We'll get a 1, and a 1. Now that's what we're after. When we work these down using our prime factorization so that the bottom numbers are all 1s, now what we know is the LCM will be these numbers multiplied together. So it'll end up being 2 to the 3rd power times 3 to the 3rd power times 7. So that's what we need to work out in order to get our least common multiple for 24, 42, and 54. 2 to the 3rd power, 2 times 2 times 2 is 8. 3 to the third power, 3 times 3 is 9 times 3 is 27 times 7. Okay, now I'll go ahead and do 8 times 7 is 56 times 27. Now I'm going to need to work that out over here. Let's find me a good spot. If you needed what I just erased, you could rewind the video or pause it right there and get that. So I want to work out 56 times 27. Of course, you can use your calculator to do this if you need. But 7 times 6 is 42. Carry a 4. 7 times 5 is 35. 35 and 4 is 39. Let's bring down that 0. 2 times 6 is 12. Carry a 1. 10, 11. So we got a 2. We got an 11. We carry a 1. We get a 5. And we got a 1. So the LCM, 24, 42, 54 is 1,512. So when you get a set of numbers that you're trying to find the LCM for, and the numbers are rather large, for me, this upside down division method using prime numbers is definitely the way to go, and that'll get me a least common multiple, which then, by the way, I can use as a least common denominator when I'm trying to work out adding fractions. All right, that's all for now. I will see you next time.